talk about hyperparameter-free approach for faster minimum-based risk decoding. So what is minimum-based risk decoding or MBR decoding? The idea is to maximize the quality of the text, and here is the equation, but you don't need to remember this equation exactly. I'm going to explain it more intuitively. So assume you have a prompt, what's in picture, and this picture is given. There's a model, which is presumably LLM or whatever language model or encoder-decoder model, whatever it is, P model. And this is going to output H, which is the output text given a context X. So these are the example outputs, like a black kitten, a black cat, or cat. So what it does is we compute the similarity between the samples using a utility function u. So this defines the distance or similarity between the sentences. And what we do is that whichever sentence which is in the center of the samples gonna be selected as the output of the minimum base risk decoding. So this is what the equation above means. So the problem of this is that yes, you can make high quality text. MBR is proven to be very useful, especially in machine learning, machine translation, but it is very slow. In fact, it requires of n squared times computation of the utility function u, which is often in neural models. So it's quite complicated. So a natural question we're going to ask is, how can we speed up the computation of MBR decoding? So that's the topic. So we start from the observation that MBR decoding is the method identification problem, which I'm going to explain it. So MBR is a process of finding the most centered data point, right? And actually, finding the center point out of the dataset is known as the method identification problem. And actually, this problem is computable in n log n time with high probability. So why don't we use this in MBR? So we propose adaptive minimum base risk decoding, which is actually very simple, that we just use the best known algorithm for the method identification problem and just place it for MBR. To sketch the algorithm of how this Baharov entity is done is that, so we formulate the problem of computing the MBR objective as the multi-banded problem. And we focus on evaluating the more promising candidates and discard less promising ones. And we repeat this process until it has only a single candidate. We have a pseudocode here. Although the proof for this algorithm is complicated, the actual procedure is quite simple. So I guess it's very simple and easy to implement by yourself. So does it work in real data? Yes. AMBER, which is the short of this adaptive minimum base risk decoding, is that it is 8 to 16 times faster than the standard MBR. We also did a comparison with confidence-based pruning, which is got the best paper in EMNLP, and we compare it, and AMBER was on par with it, with Oracle hyperparameters chosen for CBP. We ran an experiment on machine learning, text summarization, and image captioning, and it works in all three domains. So, to conclude, MBR decoding, what we found is that it is actually a method identification problem, and method identification is computable in n log n time with high probability. And we also did empirical variation showing that it is efficient in real task. So that's all. And we have a code uploaded, so please take a look at it. Thank you very much.